Taking a look at your PlayStation 5 today. This is shutting down when we're playing games like Fortnite and Siege. Video is definitely kind of cutting in a little bit of now. Our system just powered itself off right now. And we can see that there's a pretty significant amount of heat buildup. If I remember correctly, I think you were saying that, I cleaned this out before, but things hadn't really changed there for you. This is going to be the cause of our overheating. It's about 4.59. I'm going to take that same measurement. These pins just kind of look like high heels. And there it goes. Now, if that previous port, you can tap the cable and that signal will go out. So we got 3840 by 2160, which is indeed a 4K signal. And everything that can be washed goes to pre-soak and wash. Montoya Industries warranty seal number 137656. Taking a look at your PlayStation 5 today. Fair bit of dust here down the wells. Our ports do look good and clean here. Just in a pair using the front USB-C, 5.12 volts, and we're taking about an amp of current to charge the controller. We're connected wirelessly here. It's asking for high definition resolution settings, which is a great sign. So make sure that we've got a 4K image here. Current video output 3840 by 2160 is indeed a 4K image. And one of our chief complaints here is that this is shutting down when we're playing games like Fortnite and Siege. So I think I'm going to go ahead and put my account on here temporarily, and let's go ahead and run this and let's see if we can reproduce the issue. Looks like we're going to be able to connect to Wi-Fi here. One thing I did notice that I think is pretty strange is that your screen blacked out for just a split second before coming back on. Looks like we're going to connect to the internet though. Looks happy there. Looks like I'll be able to sign into my account, no problem. And let's go ahead and open up Fortnite. And we're in. We'll go ahead and let this run and play a game or two and see if we can get this to overheat and shut off here. So one thing I will say is that video is definitely kind of cutting in a little bit and out. I think it is because your HDMI port there is just a little bit loose. So that was just the lightest tap, and that knocked the signal out. But it does come back on. There we go. Got a win here. It's always kind of fun. Not terrible. Keep going. Okay, looks like our system just powered itself off right now. We were playing for a decent amount of time before that happened, but I have a feeling we're going to get the classic warning message that our system overheated. Gonna try and power on again. And it's not even responding, to be honest with you. So I'll give that some time to cool down completely. Just gonna look at our system with thermal camera here, while we're here. And we can see that there's a pretty significant amount of heat buildup in some of these areas. Some of these areas are actually white hot. RPS 5 has had time to cool. Going to power it back on. And it sounds like it's gonna do its normal thing. And we're gonna get a rebuild message. And I'm kind of used to normally getting a thermal shutdown message here as well. I think it's gonna pop up here now. And it's just gonna tell us that it wasn't turned off correctly. I was expecting it to tell me that it was overheating there, potentially. Okay, so we didn't get a message that was telling us that the system was too hot, but I think that's okay. I looked at it underneath the thermal camera and we saw that the system was quite hot, so I think that's really the first idea that I have here that's going to need to be addressed to get this fully functional and working the way that it should. Especially since it's running so smoothly, it makes me think that the hard drive's probably fine and that we really are dealing with an overheating issue in the situation. So I think the next step would be to go ahead and break down the system and do some general maintenance, but before we do that, let's go and take a look at the optical drive and the other peripherals. Just going to see if there's a customer disk already inside. It seems like there's going to be. Optical drive seems to be operating smoothly. It looks like we got a copy of NBA 2K17. Just going to use a known good disk that I have here. Make sure we're taking smoothly. Looks like we are. Spinning up. A little bit of optical drive noise, but nothing too bad. And we should see NBA 2K14, or sorry, 2K24 pop up here. And we do. Last but not least, we'll take a look at our other ports. Front USB 2.0, looks good. Top USB 3.0, looks good. Last but not least, bottom USB 3.0, also looks good. We're going to go and strip this down, replace the HDMI port, and we'll go ahead and get this all cleaned up on the inside as well. From the back, things don't look too bad. Looks like this was probably cleaned out before. In fact, I think, if I remember correctly, I think you were saying that, yeah, I cleaned this out before. And you cleaned it, but things hadn't really changed there for you as far as it staying cool. Looks like our warranty sticker is lifted just a little bit, but it doesn't really look like it's actually been opened. That could be from the factory like that. I've seen one or two that are kind of like that. This has definitely been peeled back though. All in all though, things look pretty good here, pretty healthy on the inside. little bit of pet fluff in here. Gonna remove our warranty sticker. No, I don't think you've actually removed that before. Fan doesn't look too bad here. Either way, let's get completely cleaned up here. A couple of good-sized dust bunnies. Opening up our system here. My guess is this is probably from the heatsink here. You can see a bit of a collection on that side there. It's crazy to me just how many screws PlayStation uses for their systems. I never actually tried to count all of them, but there's a lot to be sure. Almost there. There we go. Screws removed. Find a corner here. And there's really no way around this part. Anytime this heatsink cover is removed, it's going to leave some of our thermal padding on this side where the motherboard is and all these components, and then some of it on the actual heat shielding there. So that RAM chip right there is a pretty good example that completely came off. This one's like half and half on both, and I guess there's some areas where it just stayed mostly on this side, and there's really no way to control it, but not an issue for us because we're going to be removing all of this anyways and getting it all cleaned up, and we'll be replacing it. Sometimes these get stuck on there a little bit. There we go. There we go. Nice and gentle there. All right. Going to politely remove this and be careful of the other side because we're going to have all of our liquid metal there. And taking a look at that PCB, this is going to be the cause of our overheating pretty much indefinitely. At least 40% of this is completely oxidized, and that liquid metal has been completely removed from here. Here on the top, there's about 10% of that I can see is oxidizing quite a bit. So I'm going to say you're probably getting really about 50% cooling efficiency off of this chip. It's not the worst I've seen actually, but it's significant and it's worth replacing all of this in here. Go ahead and remove our CR2032 battery. Then we'll go ahead and move our PCB somewhere safe for now. We'll cover this with a Captain tape to make sure that liquid metal doesn't go anywhere. I just want to see if any of these pins here are loose. It doesn't look like that's really going to be the case. I can tell that the port itself is a little bit stressed. You can see that there's some broken brackets. 1, 2, 3, 4. This one right here is hanging on by a thread. This one right here is gone. So this has been kind of pushed in a little hard before. All the pins are intact though. So it makes me think that maybe on the other side there might be an issue. I got my caliper here. Just gonna take a reading. I'm trying to see how large this gap is. Let's see. That's about 4.59 at its widest there on the inside, which is a little wide here. That's enough room to definitely have a bit of an issue. So I think there's two options. I can either squish that back together a little bit on both sides to kind of try and tighten it up a bit, but I don't like to do that. That's not my style. So I'm going to go ahead and replace the port here, and I guess I can show you on a regular HDMI port, or I'm sorry, a regular HDMI cable, why that's an issue. So 4.59 was about my measurement there. I'm going to take that same measurement and have no problems going over our HDMI cable. Let's see here. So measuring my HDMI cable, that's about 4.38. So that's about 0.2 millimeters of play there, which is fairly significant. The most amount of play that I'm kind of willing to tolerate, even on a brand new port that I install, is about 4.5. So I always measure the ports that I install, just making sure that they're not going to be loose even from the factory when we install them. But 4.5 is about the max I'm willing to go. And you can also see how on the back of that port here that these pins just kind of look like high heels a little bit, and that they're just kind of standing and are kind of stressed and being stretched to their limits there. So absolutely, we'll go ahead and replace this port. All right, go ahead and turn on our preheater here. Flux in. And now we're just going to go ahead and weaken up those joints. Gotta watch out for this capacitor that's there in the top right corner. Really small capacitor, really easy to accidentally bump or desolder or remove. Going to purposely bridge all these pins. That way heat can just travel evenly through them all. And just watching for that capacitor. I really like this hooked solder tip for dealing with that. And we've got our board flipped over, looking at the bottom. You can see this flux kind of hanging out from the factory, actually. I didn't do the best job getting all this cleaned up. Some old flux on there. But we'll do the same thing here. Looking at these pins, just make it nice and easy for us to remove our little port. aggressive head here, because these anchors are much bigger. And I'll let this kind of soak its way in. Give it a few seconds on each pin. And then between the preheater and the hot air, it should be fairly quick to remove. See that right side going liquidous, left side starting to go liquidous. Let this really heat up and sink in. Also want to make sure that those pins on the other side are getting enough heat so we don't tear out any pads. That's always a pain to repair. Okay, ports are already loosening up there. Just let that heat a little longer. There it goes. Just fill right out. Show you the HDMI port here. All out. Let's go ahead and do a light cleanup since we're here. Might as well. Go ahead and remove that metal that we have installed in these vias. Let that reach liquidus again. Just come on in. Liquidus. Looks like it's starting to go. Great. Looks like we're going to get a little discoloration on that left side there. That's all purely cosmetic. Outside of that, this back part of our port looks completely healthy. Let that dry. These joints don't have to be perfect, but I do want to make sure that we'll be able to install our new port without having too much of the old alloy in there. There's a little bit of the old alloy in that bottom left one. But all in all, that looks really good. One last quick little sweep of the area. And it's going to go through a parts washer, so we'll get this super clean later, but clean enough for now. And here's the other side of our board, and I know that looks burnt and bad. What I'm planning with you is just the flux that's burned here. And we just kind of need a A little bit of a cleanup. There we go. That looks a lot better, doesn't it? Let's go ahead and remove the old solder from this side of the board too. And then we can do what we came here to do. Let's just replace this port. Remove our old flux. I'm sorry, the old solder paste. The old solder using solder flux. I'm going to use a more flat tip for this drawer. Camera actually adds just a little bit extra challenge having it here because it's right here next to me. Watching out for that tiny capacitor. And we'll come back through. Bring that up again. Looks like there's a pad there in the middle. It'll stay pretty well attached. That away a little better. Let's try to work away that one a little better too. Right, let's add more solder to the board. And I'm going to switch down one last time to a finer tip for our pins in the middle. And then to our wide chisel tip again for those anchors on the sides. Sorry if I'm shaking the camera a bit. Kind of a weird angle. Trying to film this and solder at the same time. Yeah. The camera is in the perfect spot to be in my way. But I don't think I have a better spot for the camera, so I'll just have to work with it. Start getting stuck like that, just add more flux, increase its flow. There we go. Touch up all these pins one last time. Just ever so gently. Get ready for that new port. Alright. Go ahead and prep our anchors. There's a lot of different ways you can solder in these ports. You can do it manually by hand the entire way through. I like a method called hot swapping, so that's what I'm going to prepare for. Let's fill in all these anchors. set. What else here? This isn't really necessary, to be honest with you. Could have just moved on to the next step. But I just like to make sure everything here is sunk. I'm going to try and take this off of autofocus as well. I didn't want to come off of autofocus, so only other logical thing, just move this down just a hair. But looks pretty so far. Let's go ahead and get a port ready. Got a brand new port here, but everything's made in China, so there's no guarantees that it's actually going to be a good part. So I measure it. And that one there, it's coming out about 4.49. Oh, that's my, had a wrong angle on it. 4.46. So that's going to be within tolerance for me. So let's go ahead and install it. This is a challenging model for this method I'm about to do because we've got the slot here on the bottom where we can kind of come through and melt things if we're not careful. So we just have to be extra careful when we install this port. Let's get this ready. Should be about it. Got this board pulled down a bit, and now I'll do a cursory clean here. Just remove some of this excess flux so you can see the work that we did. Got our board turned around here so we can try and get a good look at the work that we've done here. Spend some time cleaning here so I can get a pretty good visual inspection. Give me a second. I agree to ISO this time. Grade ISO, and then also come through here with a flux cleaner. And they're pretty good now. Keep in mind we're also going to come through here one last time by putting this through a parts cleaner. Parts cleaner should get all this area pretty darn close to factory again. And then I'm just gonna check the integrity of every pin just by pressing firmly on it from every side. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19 very solid pins here. I'm also just gonna take out our board real quick. And I want to take a look at the solder fillets on the side. Let's see here if we can get that into camera view. Those anchors on the left look very good. Anchors on the right also look very good. Everything here is pretty darn close to factory. Looking at the anchors on the bottom, I just want to make sure I can see the pins for each and every one of these, and we've got a nice solder fillet that fills every void there. So, all in all, that port there looks fantastic. Just gonna take the time here to double check every pin for throughput. How I'm gonna do that is I got two multimeter leads. When there's an electrical connection, we'll be able to hear a beep in the background like we just did. And yeah, I guess I'll show you exactly what I'm doing. I've got a breakout board here behind the camera, and I'm just going to touch every pin underneath the port and touch the throughput pin. On the breakout board, just to make sure we have electrical continuity. So this will help tell me that we've got a good solid port, that everything's connected, and it'll also tell me that if there are additional issues going on here, that they're not related to our port when we come back for testing. Sorry, I'm not trying to shake the camera so much, but I have a little bit of a rudimentary setup for now. Okay, just going pin 1 to pin 1, looks good. Pin 2 to pin 2, 3 to 3, 4 to 4, 17, 17, 18, 18, and last but not least, 19 to 19. So all of our pins have good throughput. That's exactly what we want. So I'll go ahead and tilt down. And now I'm going to test for the opposite. Now we don't want continuity between these two pins, because if we do, that's going to tell us that there's a bridge and there's a short circuit between the pins. So between pin 1 and pin 2, we look good. 2, 3, good. 3, 4, 4, 5, 16, 17, 17, 18, 18, 19. No continuity between pins. That's exactly what we want. This should be a great HDMI port. And I just want to do a quick test here. So we got everything in a very basic setup. Just want to make sure that we're still getting a good clean 4K signal with that new HDMI port before we strip it down completely and get this system cleaned up. The PS5 logo, always a great sign. Now with that previous port, you can tap the cable and that signal will go out. Very pleased to say that is no longer the case. That is a strong port. Just going to sign on to a guest account here. Come over here, my wireless controller. Just want to make sure that we're still getting a 4K signal. So we got 3840 by 2160, which is indeed a 4K signal. So we're happy. I'll go ahead and power the system off again. And let's go ahead and get it washed. And let's go ahead and get it prepped for final reassembly. One last disassemble. I'm curious to see what our heatsink looks like underneath everything here. Because that's also a fairly common culprit for overheating issues. These brackets have just been sticking for me all day. And there's a fair bit of dust here, but honestly, this isn't as bad as I was kind of expecting. Got a decent amount of dust here in the bottom of our case. Looks like the power supply is fairly choked out here. Great. Let's go ahead and get this all cleaned up now. Yeah. There's going to be a lot of oxidization here. You can tell this whole section here isn't going to want to come up easily. So we're going to have to work on that pretty good. Go ahead and remove all this old thermal padding. It's pretty useless to us at this point. Go ahead and remove all of our old thermal materials here. Same with either side. This side's a lot more tedious though, just because of this power rail down here. We kind of just shellac that with all that thermal material. Still have a decent amount of this oxidization here, so we're going to take care of this now. It's going to start a chemical reaction here. We're just going to take an oxidization and do our best to change it into an alloy here. Let this sit here for a little bit. That's where the heaviest part of the oxidization is. You can see all those brown bubbles kind of forming there. And just letting this chemical reaction take place here. You can see that's becoming an alloy and becoming very brittle and breaking up quite quickly. You can see all of that oxide being pulled up underneath. It's an exothermic reaction. There we go. I'm pretty happy with that. We'll go in and pull up all that oxidization now. Maybe I'll get a thermal camera and show you how hot that's getting. It's telling me it's probably in the range of about 110 at its hottest point. Honestly, I feel like it gets a little bit hotter. I just know that when it gets super hot, I do have to drop it and let it go sometimes, but We're at the end of the reaction. You can see all that powder that it kind of creates. We'll just get all that cleaned up now. And this one's pretty bad, so we've got quite a bit of oxidation in here still. So we're going to go ahead and polish this, and if it doesn't take the polish, we're going to go ahead and have to sand it back a bit. And if it doesn't take the sanding and there's still quite a bit of oxidation left, the next step is to go ahead and sand it completely, and then we're going to have to nickel plate this again and bring this back up to a place where we've got a good layer of nickel plating, and we're able to get a good clean connection between the APU and the main chip, that is, and this heatsink. Let's see. Oh, that's still coming up. And yeah, that oxidation, it's pretty bad on there. I'm gonna clean up all the polish we threw around. And we'll keep going. Unfortunately, it does seem like sanding here is going to be enough, but when it's not enough, this entire layer needs to be stripped back, and then this all needs to get nickel plated again. Okay, we're getting to the place about as comfortable as I'm going to be sanding this top layer. And that is so much better than what it was. And there's a couple of areas here that are still stained, but those are just stains. And we were going to have a good solid connection of liquid metal between this surface and our chip again. So we're going to go ahead and polish this back one more time, and let's get this ready for new liquid metal. The only disadvantage of using that Dremel is it does throw a decent amount of polish everywhere. Buff out that last layer of polish. And I know that there's still a bit of staining up here, but that's going to be purely cosmetic in our case, or at least mostly cosmetic in our case. And this is going to work great. The only way to get rid of all that completely, for one that's this badly oxidized is going to be sand everything back and to replace all the copper, which is not really an option. Well, it is an option, but it's not really an option I want to entertain because I think this is going to work just fine. And everything that can be washed goes to pre-soak and wash. Some of these scrapes in here are pretty rough, so gently work them out once we can and once we can. Be careful around these edges here. Brand new, fresh liquid metal. And we're going to get full coverage again. And there we are, a good solid surface of liquid metal. After that parts washer there, this all looks super pretty. Very happy with how that came out. And then there's that HDMI port. It does, man. It looks pretty much as good as factory. Pins on the back. You can see each of those individual anchors there. Exactly what we want to see. Good, good fillet on those solder joints. Next, we got to do the same thing with your computer board, or a computer specifically on our PCB, also known as the APU. This one's a lot easier, but you can see that it's in fairly bad shape here too. So, let's get started here. And we're just going to get off most of this. I mostly care about the main die here being super polished and super clean. And make sure that we get rid of all the oxidization. The metal that they use for the die here is a lot friendlier to work with than the nickel that they use on the heatsink side, so we can get this cleaned up a lot easier. I should also say that it's a lot more fragile, so I don't use the same processes that I use for the heatsink side. And then this die takes really well to polish. I'll go ahead and use a lintless tip here though, just because I don't want to introduce any debris that are going to affect our effectiveness for cooling here. Had a little bit of liquid metal jump there. I'm gonna have to get that cleaned up. Fortunately, it's there, not on the PCB, but always a fairly dangerous thing, because if that gets into the wrong places, it will cause some issues pretty much in a guaranteed way. Kind of like to just pick up liquid metal by doing a little bit of a roller effect, going the opposite direction until I can get it. Final buff. How's that? Looks pretty good, huh? There's the tiniest little speck there. That's not going to come up. But quite happy with that. So we'll go ahead and put our liquid metal layer on. Liquid metal applied. This part's always a little stressful because we just gotta make sure that we're not spilling any liquid metal anywhere. So just gonna come down gently with this. Make sure everything's lined up and snap it into place. Ribbon cable just doesn't want to go where I want it to. Montoya Industries warranty seal, number 137656.
Most people. See more there? Last name, Butts. Just a sec. Hey, is there a Butts here? See more Butts? Hey, everybody, I want to